Hello, this is Line Seiki's webinar, What You Can't Miss for Length Measurement. And the title is Length Sensor In-Depth Study. Are you interested in or encountering any problems in measuring the length of anything? If so, this webinar might be worth watching, so let's get started. First of all, let's check the basic points of length measurement. Length measurement is action to determine length of an object by using a tool. A measuring tape or a ruler would be one of familiar examples. You might have few chances to use a caliper at home, but it's also the tool to measure length of an object. And what these tools have in common is that they are supposed to be put right on the object so that you can measure the length. Then how about this one? Perhaps some of you guys may have seen it before. This is a road measure. When you roll its wheel on the ground, this part, we call it a counter, starts to increase the value so that you can measure the distance that you have rolled the wheel. This tool is used on the field of school and road, for example. And Line Seiki had several tools for length measurement, so let me introduce them briefly. First, we have length measuring counters. They are mechanical type. Another one is a length sensor. So roughly, Line Seiki has two product families. A length measuring counter has two wheels and they rotate on a measuring object. You put the counter on the object, such as cloth or plastic film, like this. When the object moves, that motion makes the wheels rotate like this. As a result, the length of an object can be measured. A lot of length measuring counters are used in the industries of textile, non-woven textile, or film manufacturing factories, and so on. And this one is today's subject, length sensor. Let's have a look at this. A length measuring counter has a display to show measured length, but there is no display on the length sensor. Then how do we check the measured length? From this chapter, let's focus on the length sensor of Line Seiki. Our length sensor is called CT1 series, and another name is pulse generator for length measurement. A pulse is current that flows for only a moment. The length sensor can generate pulses, and this is an electronic counter. Connect them like this. When the wheels of the sensor rotate, pulses are sent to the counter along with the movement of the wheels. As a result, measured length can be shown on the display. When you use a length sensor, measured value is displayed on such device as an electronic counter. Now then, let's check the features and specifications of CT1 series in detail. There are some important points. First of all, let's check resolution, or fineness of scale. Length sensor generates and outputs a pulse in each resolution. For example, if you want to conduct length measurement in millimeters, choose a model that outputs one pulse every 1 millimeter. And CT1 series has 4 resolutions: 1 meter, 0.1 meters, 0.01 meters, and 0.001 meters. You can choose any of these resolutions according to your needs and purposes. And by the way, the diameter of the wheels is 106.1 millimeters. Therefore, the circumference is 1/3 meter. So 3 revolutions of the wheels equal to 1 meter. So the next item is this one, count up, count down. Probably the title doesn't make any sense, but let's move on. CT1 series has 2 kinds of models, count up only models and count up and down models. First, let's check the count up only models. They output pulses only for count up whichever direction the wheels rotate. On the contrary, count up and down models can output pulses that decrease the display value of an electronic counter when the wheels rotate backward. Now let's move on to the next item. 3 kinds of outputs. Our length sensor make different outputs according to models. First of all, contact output. This is circuit diagram of contact output models. When the wheels rotate, the microswitch snaps close, and the current flows and a pulse is output. When the wheels rotate again, this time the microswitch snaps open, so the flow of current is stopped. And when the wheels rotate again, the microswitch snaps close, the current flows, and the pulse is output. Contact output models of CT1 series output pulses in this way. The next one is voltage output, and it branches into 2 groups. One output models, it has only one output and enables count up only. This is circuit diagram of output. Current flows like this. There's only one exit for the pulse to go out from CT1. On the other hand, 2 output models have 2 exits for the pulses to go out. And this is the third and last one, open collector output. This one also branches into 2 groups. One output models that enables count up only. They have only one output. As you see, there is only one exit for the pulse to go out. On the contrary, 2 output models that enables count up and down have, of course, 2 exits for the pulses. Well, we saw count up only models and count up and down models, and the models with one output and 2 outputs. Let's see more details about these differences in output, and let's wrap up such differences. Length sensor CT1 series has 2 kinds of models, count up only models and count up and down models. Count up only models have one output. On the contrary, count up and down models have 2 outputs. Regarding count up only models, the form of the pulses is like this. It's square. They are input to an electronic counter. In this waveform, this part, this is the waveform of count up. When a pulse of this waveform comes in, the counter increases its value. In this example, there are 1, 2, 3, 4, 5, 6 squares, so it's 6 counts, and the count value increases by 6. And here's a tip. You can also use these models as a count-down only models. Just connect CT1 to an input terminal for subtraction. Every time a pulse is input to the terminal, count value will decrease. Now let's see the case of count up and down models. They have two outputs, A and B. From these exits, pulses are output respectively, and then input to an electronic counter. In the first place, please have a look at this part. The upper square is the pulse that came from output A. The lower square is the pulse that came from output B. And this is the waveform of count up. Do you see that the square B is shifted to the right a little? When the two pulses are output in this way, an electronic counter adds 1. In this example, we can see this combination in total 3. So the electronic counter increases its count value by 3. Now let's see this waveform. The upper square is the pulse that came from output A. The lower one is the pulse that came from output B. And this is the waveform of count down. When you look at it, you will see square B is shifted to the left a little. When the two pulses are output in this way, the electronic counter decreases the count value by 1. In this example, there are 2 waveforms of this combination. Therefore, the electronic counter decreases its count value by 2. When the wheels of CT1 rotate in a direction, waveforms of count up are generated. And when the wheels rotate in the opposite direction, the length sensor generates waveforms of count down. Now I'd like to share some notes for voltage output models. Length sensor CT1 series has the models with contact output, voltage output, and open collector output. When you use the type of voltage output, connect the sensor to an electronic counter and then apply voltage so that you can make the counter perform counting. But if the voltage is insufficient, the counter does not perform counting. To avoid such a problem, we would like to show you how to calculate input voltage that is applied to a counter. So, before starting the calculation of input voltage, there are 2 points to be checked. The first one is, how much input voltage does the counter require? In case of our electronic counter E21 series, it requires 6 to 30 volts DC as input voltage. The second point is, how much is the impedance at the destination? In case of E21 series, it is 7 kilo ohms. Now based on these points, let's start the calculation of input voltage. This diagram describes the output circuit of CT1 models of voltage output. In this one, it shows the input circuit of electronic counter E21. CT1 requires power supply, so let's make the counter supply 12 volts DC. This current runs through into CT1 through the impedance of 3.9 kilo ohms and then comes out from CT1 and runs into the input part of E21. To make it easier, I will transform the part that shows the flow of current into a simple sketch, like this. So the electricity starts to flow from the left side inside of CT1 and is 12 volts DC. And as the electricity goes through the two impedances, the voltage gets lower. First, the electricity goes through the impedance 3.9 kilo ohms inside CT1. Now the voltage dropped a little from 12 volts. Second, it goes through the impedance 7 kilo ohms inside the counter and dropped to 0 volts. The voltage dropped from 12 volts to 0 volts. Therefore, this means the voltage dropped 12 volts in total by running through two impedances. And by the way, the amount of voltage that decreased at each impedance equals the amount of voltage that is applied to each impedance. In other words, voltage that is applied to impedance 7 kilo ohms is input voltage applied to the counter. Looking at this picture, the voltage dropped more at impedance 7 kilo ohms. But how much did it drop? In fact, 12 volts is shared between the 3.9 kilo ohms and 7 kilo ohms. And the sharing ratio is impedance at CT1 to impedance at E21. In this picture, 12 volts is shared at the ratio of 3.9 to 7. If you grasp this ratio, we just play mathematics. The input that is applied to the counter can be calculated in this way, and it's 7.71 volts DC. So here, the 7.71 volts is applied. Input voltage of E21 series is 6 to 30 volts DC, therefore we can confirm that the voltage is sufficient in this case study. Now then, let's move on to the next case study. How about connecting CT1 with large counter G90 or G95 series? We'll play the same mathematics again. Check the impedance of CT1 and the impedance of large counter and calculate in this way. Unfortunately, G90 or G95 series requires 10 to 30 volts DC as input voltage, so 3.49 volts is not enough. However, there are two measures to solve this issue. The first measure is select open collector input for input setting of G90 or G95. The other measure is use CT1 models of open collector output instead of the ones of voltage output. By adopting either measure, you can use the large counter G90 or G95 series with length sensor CT1. To end this webinar, let's run through some points to be checked to choose the best model for you. This will be some kind of quick review. Depending on the model, the running speed of CT1 series have some variation, from 24 meters per minute model to 700 meters per minute model. Please consider the speed of production line at a factory where the measuring object is manufactured. And there are 4 kinds of resolution: 1 meter, 10 centimeters, 1 centimeter, and 1 millimeter. The best resolution will depend on your application. Is 1 meter resolution precise enough, or should it be in millimeters? Please check how precise it should be on the factory floor. Length sensor CT1 series has count up only models and count up and down models, and there is some variation in its highest running speed. Resolution can be chosen between 1 meter, 10 centimeters, 1 centimeter, and 1 millimeter. And there are 3 kinds of output. Think about each element and choose your best model. So that's all for this webinar, Length Sensor In-Depth Study, what you can't miss for length measurement. We hope you find it informative, but if you have any questions, please check our contact information that will be shown when my face disappears. Thank you very much.